Imagine a world where you can get high-speed internet anywhere on Earth, even in the most remote villages, deserts, or mountains. A world where your connection doesn't rely on fragile cables or local infrastructure. This is no longer science fiction, it's the reality being built right now in space. Welcome to the race for the next internet. Starlink and other satellite networks aiming to change how the world connects. Space-based internet networks use hundreds, sometimes thousands, of satellites orbiting the Earth to beam internet signals directly to your devices, unlike traditional internet, which relies on cables, fiber optics, and cell towers. These satellites create a global web of connectivity from above. The most famous of these is Starlink, a project by Elon Musk's SpaceX, but Starlink isn't alone. Companies like Amazon's Project Kuiper and OneWeb from the UK are also launching satellites to compete. And this global race, the goal, provide reliable, fast internet to every corner of the planet, even in places where connectivity has been impossible for decades. So how does it work? Traditional satellites sit very far from Earth, causing delays in data, also known as latency. But these new networks use low Earth orbit satellites much closer to the planet, drastically reducing lag. A user receives signals to a small satellite dish on their roof, which communicates with these orbiting satellites. The satellites then connect to ground stations that link to the global internet. It's a fast, efficient system that can bring internet speeds comparable to urban fiber connections even in remote areas. But this isn't just about convenience, it's also a global power play. Governments are watching closely because controlling access to the internet can influence education, economy, defense, and even surveillance. Countries like China, Russia, and the United States are investing heavily in satellite networks. Meanwhile, private companies are racing to deploy satellites faster than their competitors to dominate the future of global connectivity. Whoever controls this network has not just a technological edge but a strategic geopolitical advantage. Space-based internet isn't just a tech marvel, it could change lives. Remote communities can access online education, telemedicine, and even global markets. Disaster zones, where traditional infrastructure is destroyed, can get instant connectivity. For the average person, it could mean faster streaming, better gaming, and more reliable remote work even while traveling. In short, it could bring the world closer together digitally. But there are challenges. Launching thousands of satellites risks space congestion and collisions. Astronomers worry about light pollution affecting observations. And as connectivity spreads globally, cybersecurity and privacy become bigger concerns. Plus, affordability is still an issue. The race isn't just about launching satellites, it's about making this technology safe, secure, and truly accessible. In the next decade, space-based internet could reshape industries, societies, and cultures. Imagine VR classrooms anywhere, instant communication and disaster relief, global gaming tournaments without lag, or even entire countries skipping traditional internet infrastructure. This is a technology with the potential to level the digital playing field. But it's also a reminder of how interconnected our technological and geopolitical worlds have become. The race for the next internet isn't just about faster downloads or better streaming. It's about changing how the world connects, who controls access, and what the future of global communication will look like. The question is no longer if space-based internet will take off, it's who will lead the way. If you want to stay ahead of these groundbreaking trends, hit the subscribe button and join us as we explore the technologies shaping our future.